Good morning everyone. So last time we have seen about sound waves which are produced by the vibration, and not only that, we have seen that for propagation of sound waves generally they need a medium like a water, solid and air. If there is an air, water or a solid, generally it propagates due to the particles present in its medium, and due to that particle just a disturbance which is created by that sound waves or a vibration, that disturbance just flow towards the object that hears that sound or needs that sound, right? Actually the particles does not move on the disturbance flow, and which is known as waves. Then how these type of waves can be flow in a medium, and what happens actually in a medium, that we are going to see. Generally just think about one tuning fork, right? Just think about it. There is a tuning fork. So here is a tuning fork. Okay. And the sound is produced when it vibrates. Okay, generally vibration means it just goes in a forward direction and the backward direction like that quickly. So when it just goes in a forward direction, it applies a force that particle present in the medium here to it. So I am just taking a vibration like that. So it just vibrates from its central position. Okay? And when it just goes in a forward direction, the particles near the medium just apply a force on it, and just because of that they just move in a forward direction. And as it moves in a forward direction, a particles which are near to it becomes more. So more particles are present at here. Understand? When it just goes in a backward direction, these particles comes again on its original position, and the another half will go in a forward direction. Like that, we are thinking about this position. Then what happens? The particles are here are moved. Like that. Due to the vibration, it just goes in a forward direction. So the particles becomes moved. And as it goes in a backward direction, these particles comes again on its original position. So particles becomes less. The particles which are generally at here, which just goes in a forward direction, comes back on its original position, as I say. And another particles go in a forward direction. So this will also becomes less. And here a more particle will be present, as the particle from the below side or a backward side just come at here. So particles become small at here, because just think of it. There is a medium like that. There is a particles. As the vibration of this comes at here, just so there is a more particles at here, and here it is less, here it is also less. But as when it happens, so first of all, the first thing is that when that vibrating thing just come in a forward direction. As it comes in a forward direction, it just moves and becomes a more quantity of particles. And when it goes in a backward direction, this particle comes again on its original position. And as it applies a force on it, it comes again on its original position while it just goes in a forward direction. So accordingly, the middle portion becomes a less concentrated particles. There is a less particle because half of it comes back again on its original position and half of it just goes in a forward direction. Like that, and here also happen. So when this happens, it comes back. This one goes up here. So more particles becomes here. Here becomes less. Here becomes less. Here becomes higher. समझ में आ रहा है? जैसे ये पार्टिकल पीछे जाएंगे, मतलब कि पहले समझो कि वाइब्रेशन शुरू हुआ, जैसे ही वाइब्रेशन में वो आगे जाएगा पार्टिकल्स ज्यादा जमा हो जाएंगे क्योंकि पीछे के जो पार्टिकल्स उसने धक्का दिया साथ में ज्यादा हो गए। लेकिन जैसे ही वो पीछे जाएंगे वो जो पार्टिकल आगे आए थे वो फिर से चले जाएंगे और जो पार्टिकल यहाँ पे थे जिसपे उसने फोर्स लगाया वो पार्टिकल भी आ गए, मतलब कि यहाँ पे पार्टिकल की मात्रा कम हो गई, मतलब यहाँ पार्टिकल कम है, पीछे भी जा रहे हैं आगे भी जा रहे हैं। नाउ अगेन वो आगे जाएगा, तो आगे जाएगा तो यहाँ के पार्टिकल फिर से आगे आएंगे और ये पार्टिकल जो आगे गए थे वो भी फिर से चले आएंगे। जैसे हमने कहा था वो आगे फोर्स को ले जाते हैं फिर से अपने ओरिजिनल पोजीशन पे आ जाते हैं। इसका मतलब यहाँ पे फिर से ज्यादा हुए तो यहाँ पे कम हुए क्योंकि यहाँ से पार्टिकल वापस आए और वहां के जो पार्टिकल थे उसे आगे भेजा। तो इसका मतलब यहाँ ज्यादा, यहाँ कम, यहाँ ज्यादा, ऐसे करते करते पूरा आगे जाएगा। मतलब एक जगह पे ज्यादा है पार्टिकल, एक जगह पे अगर पार्टिकल ज्यादा है एक जगह पे कम, फिर से एक जगह पे ज्यादा तो फिर से एक जगह पे कम, फिर से ज्यादा फिर से कम। समझ में आए? तो इस तरह से पूरा जो पार्ट है वो कंप्लीट है। यहाँ पे पार्टिकल कम है क्योंकि यहाँ से पार्टिकल यहाँ आ गए और कुछ पार्टिकल चले गए। इस तरह से अगर पास यहाँ पे याद है तो यहाँ पे होगा ज्यादा, यहाँ पे ज्यादा, यहाँ पे ज्यादा, यहाँ पे। तो ये जहाँ पे पार्टिकल ज्यादा है उसे कॉम्प्रेशन कहते हैं और जहाँ पे पार्टिकल कम है उसे रिफ्रैक्शन कहते हैं। So when the refraction is occurred and when the compression is occurred, whenever the vibrating object is vibrate and when during the vibration it goes in a forward direction, generally due to the more number of particles, a pressure is increased in that region as the number of particles are more in a same volume. Pressure is increased and there is more pressure, area is known as compression. But whenever that tuning forces go in a backward direction, means a vibrating object goes in a backward direction, during that time a region with a less pressure occurs, which is known as rarefaction. In a compression, generally the pressure is also higher and the density of that medium is higher. But in a rarefaction, the pressure is also less and the density is also less. As the density is the unit volume from mass, right? A total mass covered in a unit volume is known as a density. So the volume is higher, but the mass is less and the density is less. But the volume is the same, but the particles are more, so the mass is more, so mass is more, so the density is more. So the compression is a higher density region, while the rarefaction is a less density region. So you can say that the sound can propagate in a medium by a change in a density or by a changing in a pressure also. Not only that, sound waves are also known as mechanical waves. Why it is known as mechanical waves? Because for propagation, it needs a medium. It needs a medium. If there is no medium, then sound can't be propagated. Whenever you are in a space and you want to talk with your friend, if you loudly speak anything after that, your friend can't be hearing because there is no medium. For propagation of a sound waves, you need a medium, any type of medium. It can be a air, liquid or a solid. And it can propagate from any medium. But if there is no medium, you can't propagate a sound. You can't hear it, you can't propagate from one position to another position. There is one activity is given to you for that. So first of all, what you have to do for that? Then you have to take a one bell. Right? And you have to hang an electric bell inside of it. Right? You have to hang an electric bell inside of it. There is two wires which are connected with the batteries. So here is electric bell, and here it is vacuum. Now, when you connect these two wires with a source, and when you apply electricity inside of it, the electric bell will ring. And as it rings, you can hear the sound of it. But if you shut all the air from it and create a vacuum inside of it, and now whenever you try to switch on the bell will ring, but you can't hear it because there is no medium inside of it. And from this practical, you can say that for propagation of sound, we need a medium. If there is no medium, the sound can't be propagated. This type of one activity can be also asked you in your exam. Understand? So how can you say that? Just explain the activity which shows the sound waves are mechanical waves. That the mechanical waves means the waves which need a medium to propagate are known as a mechanical wave. Then sound wave needs a medium to propagate. It can be easily propagated in an air, liquid or a solid. For that the activity is there. Take a one bell, put a electric bell inside of it. It should be a purely air shield. That the air can't be come inside and go outside of it. Just connect a one vacuum pump with it. Now, just switch on the electric bell. Now try to hear it. You can easily hear the sound of electric bell. Now use a vacuum pump to shove all the air inside of the bell jar. As the air just come outside of the bell jar, the sound, the intensity of sound becomes less and less. And when there is no air inside of the bell jar, you can't hear the ringing of a bell. And from this practical, you can say that for propagation of sound, we need a medium. Without medium, we can't hear a sound. So like that, you can say that the sound need a medium. Without medium, it can't propagate. Generally, the sound waves can't hear or can't propagate inside of the vacuum. Understand? Where the mediums are not present. So here it is our topic that a compression and rarefaction by which the sound can be flowed. Right? Once again, I just tell you, whenever the sound waves are flowing from a medium during that time, a compression and the rarefactions occurs. Understand? So whenever the vibration is occurs, when it goes in a forward direction, due to the high pressure area, the compression is occurs. And whenever it just goes in a backward direction, due to the low pressure area, the rarefaction is occurs. So the sound waves are generally propagated in a medium by the compression and the rarefaction. So due to the compression and rarefaction, you can say that in a compression, the pressure of that medium is higher. Not only that, the density of that medium is also higher. But in a rarefaction, the density is less and the pressure is less. Just because of that, you can call it a pressure oriented or a density oriented waves. Right? The waves can be flowed due to the density difference or due to the pressure difference. Not only that, we have seen that the sound waves are the mechanical waves, so it takes a medium to propagate. If there is no medium, it can't propagate from it. For that, there is one activity. You have to take a one bell jar, put an electric bell inside of it, and a one vacuum pump should be connected with it. Right? Whenever you just switch on the electric bell, you can easily hear it because there is an air inside of it. Now use a vacuum pump to shut the air. As the air becomes less and less, the intensity of that sound that you can hear becomes less. And once When all air are just removed from that bell jar, it becomes vacuum. There is no medium. Just because of that, you can't hear a sound. And from that practical, you can say that the sound waves are the mechanical waves. Understand? Now the another topic that we will see